Hello, everyone. If you were absent on Unit 0, Lesson 2, so for A day, that would be 819. On B day, that would be 820. We talked about the scientific method. So I'm going to talk about how we use this in everyday life and give you an example for help on your assignment for this second day of science. So we're looking at the scientific method on the screen. This is in a set of slides that's linked on Canvas. And these are the steps of the scientific method. Many of you have seen this before, but a lot of times we just memorize the order and that's it. We don't ever use it. And we use this when we write lab reports. We also use this when we do experiments, but we also use this in everyday life. So our very first starting point is usually a question. Sometimes it's a problem that we have. So in our case, we're going to use the example of a flashlight that doesn't work. So I have a flashlight. It does not light up. It does not do the job of a flashlight. I need to figure out how to fix it. So my problem is my flashlight is broken. It doesn't work. My question is, how do I fix the flashlight? How do I make it work? Things I already know about a flashlight would be included in my background research. Sometimes it's research, sometimes it's stuff you already know. So my background research about my flashlight would be that I already know that it needs batteries. I also know that it also needs a good light bulb. So those are two things that I already know about a flashlight. My hypothesis is what I'm going to do. So I'm going to start with the easiest process of fixing my flashlight. I think that's replacing batteries. I have batteries at home. I don't have a flashlight bulb at home. So my hypothesis is an if-then statement. If I change the batteries, then my flashlight will work. That's what I'm going to test. That's what I test in my experiment. Experiments are usually step by step. Sometimes our procedure doesn't work as well as we want it to. Sometimes you don't have batteries at home. Sometimes you need something that you might not have right in front of you. So my experiment would be to replace the batteries in my flashlight. I'm going to take out the old ones, put new ones in, and then test my flashlight. If I don't have batteries, my procedure doesn't work. I don't have new batteries to put in, so I have to troubleshoot. I have to go and get the batteries. I can then do my experiment. If my procedure works, if I have everything, then I can get some data at the end. Data doesn't have to be numbers. It can be an observation. The flashlight works or it doesn't. And if my flashlight doesn't work, that means that I'm going to have to circle back. If it does work, then that's great. I can help somebody else fix a flashlight that needs new batteries. Right here, my results align partially or not at all with my hypothesis. If I replace the batteries and my flashlight still doesn't work, I go back to the hypothesis. I know that this time it's not the batteries. I'm not going to test that again. I'm going to figure out something else. So I'm going to change the light bulb this time. If I change the light bulb, then my flashlight will work. I test it. I go and I get the light bulb. I change it out. I then test and get data from that test. So I turn on the flashlight. This time it works. My results align with my hypothesis. I can then help someone who has a flashlight that's broken. That's communicating results. Scientists help each other all the time by communicating their results from their studies so that someone else doesn't have to do it again and try all these steps again. If you know that it could be the battery or the bulb, you can do 2 quick experiments right away to figure out which one it is. So this scientific method we use all the time in everyday life. That's what you're going to practice on your assignment for today. So your assignment is called Think Like a Scientist. It's in your assignments. It's also linked right below here in the Unit 0 Day 2 agenda. Bye.